Hi everyone, are you able to hear me clearly? Alright, alright. Should we start now? I think I should make somebody. The. Okay. Anand, is it okay if I make you one of the organizers so that you can start recording? Alright. Is my voice breaking to others? Okay, okay, okay. Is your connectivity okay, Anand? If your connectivity is okay, then we can make you the one of the organizers so that we can start recording. Alright. Let me. Alright. Then let me make you the organizer. And okay. All right. So now you can start recording. You press the record button. All right. Have you started recording? Have you started recording, Anand? Should we start now? Hi, Anand. Should we start now? Have you started recording? It's under screen sharing. You'll see a tab called screen sharing. Are you using Mac or Windows? All right. So let's start now. Good. So yesterday we talked about how we created a table, how put some data into it, and we also talked about the data model of HBase, right? So we were about to discuss the physical storage. We are about to discuss the physical storage of the data. So the physical storage is generally at this place. The one which we discussed yesterday, if we go into h1.cloudxlab. So if you go into the file browser, you'll be able to confirm that HBase stores data in the HDFS. As we had discussed again and again, the the HDFS is the baseline for most of the services. All right. So let's see if this apps HBase data default. Okay. Let's go here. We say data default. Okay. So inside this folder, do you see your table yesterday? The table we made yesterday, if you remember? Under that, do you see this is the name? So this is the folder in which all the data is stored, under which you see the table name. Under the table name, do you here this is the name of the region. So after table, first is the table name, then region ID, and then column family, then store ID. So this region ID is automatically generated. And then these are the column families. Do you see? Do you remember our yesterday's discussion? We talked about two column families. One is contents and other is anchor. So you can see that. All right. Now, under anchors is your store file. This is the actual file where the data is stored. So this file is in binary format, so you may not be able to see exactly what is there inside this file, but you will be able to see the name. You remember we said hortonworks.com, then we said anchor, and all of those values are inside. All right. And this file is filled with zeros after a point of time, so that if you are adding more data, this data will be here, so that it doesn't have to create another file. All right. So we are able to confirm that the physical storage of a table is in HDFS. Good. All right. So, quick point to all of you again, that that the row updates are atomic, no matter how many. Okay, how many updates? So each row can be updated in an atomic way. Meaning, if you are trying to do multiple operations on a row, put this key value, put this key value, put this key value, delete this, delete that. So you can combine a lot of such operations into a single transaction, and thus per row we can create transaction. All right. All right. So that was a quick update about HBase. There's a question from Rohit. The question is, all right. Question is, where is the threshold defined for region server? So the threshold is defined if you go into Ambari. There you will find the threshold for HBase. There is a in file system, there is a file called hbase site.xml. There you will find the details about the maximum region server. Okay, so you can see that, not this, not this. All right. So here it is there generally. All right, let me have a look. So it actually here this is there is one of the properties on here where we say that this is the size before the compaction. So one is that the record size specifies the combined record allowed for key value. This is the upper boundary of single entry saved in the storage file. Since they cannot split, it helps avoiding that the region cannot be split any further because the data is too large. It seems wise to set this a fraction of region server. So uh, there is a way to. Yeah, here. Do you see that? So if the sum of the sizes of the regions H file have grown to exceed this value, the region will split into two. All right. So this is what it is. And good. So right now the region size is around 10 GB. All right, going ahead. Now Just now we used, in the last session, we used scan to go through the full list of table. And in our case, we could have gone to HBase shell and what is the login SSH? Yeah. So here we have HBase shell. Okay. So this is the HBase shell, and yesterday whatever table we created, we can go through it by saying web table. Okay. So that is a command line way of doing it. But if you have to do it programmatically, then you can use then you can use HBase scanners. HBase scanners are like cursors in a traditional database. They have to be closed after the use. Scanners returns row in order, and on the order is the row key values. Okay, so they return the records based on the row keys, and then scanners return. I mean, the users obtain the scanner by using this kind of a Java call. So in your Java program, if you want to call HBase and want to read it, first you have to define scan in an object which is defined based on the starting point of row, which row key to start it, which row key to stop it, and which columns to return. And optionally, if you want to run some filter on the server side, we can run something here. All right. So all right. So we define a scan parameter which defines that from which row to which row and how many columns, and if we need to specify some logic to run on the server side. So after that we can call result scanner with the scan object, and it will give us the handle to the result. And just like cursor, we will have this. Afterwards, we can keep on invoking next and provide a number of rows, how many rows we want, and it will keep on tripping back to region server and will give you the complete records. Okay. A question from Rohit is, and the version is also configured in the same manner? The versions, yes, that's right. So versions you can configure while creating the table as well. Versions you can good point. So versions you can configure per table and per column family. Okay, so you can define it per column family, and that can be done while creating the table. All right. Now, if you are interested in looking at the Java code, if you want to the access your HBase via Java, then you can have a look at this kind of code. So it's little too verbose. Actually, it's here till here it's just creating a table, and then here it's checking if the table is created, and then it's trying to read the data. Okay, so it's a little too verbose. It's intimidating for those who are not Java programmers. So those who are comfortable with Java, let me just go through it. Although it's not too much, you know, too big a deal. So you create a config object first of all. Once you have created a config object, then you create this admin handle. Admin handle is probably the most important one, because using admin handle, you will be creating table, you will be creating various kinds of operations like delete, update, So those operations are done using the admin handler. So you create an instance of HBase admin, providing the config object. If you want to change some config, you can change the config here before passing it to HBase admin. Afterwards, you can make a call to htable descriptor by passing the name of the table. So we are creating an object for the name of the table, and then we are creating the column or column family, you can say. And once you have created the column family, you can add that column family to the table, and then add this table to using admin. We are saying admin create this table. And what is this table? This table name is test, and it is going to have a column family called data. And once it's done, we can again ask admin to give us the list of tables, and then go through the list of tables and check if it exists or not. All right. This is supposed to be the new line. So after that, we can, if you want to add something to a table, we can use this kind of syntax. First, we get the table name, and then we say this is my row number, row bytes. Based on the row bytes, we create a put. Put is one of the objects, and using put, we'll be putting the data. Okay. So we'll say p1 dot add, as in we will say for this row, this is the data we want to add, and then we say that tables dot put p1. So that will put this data into this row. Okay. And after that, you can do the get and get the records. All right. All right. So if you are interested in running MapReduce on with HBase, you can run that in the exact same manner the way we have run our MapReduce. We can also execute the MapReduce on the HBase table. All right. So a little recap. In our MapReduce, in our traditional MapReduce, the input was the file located on HDFS. Okay. And here the input is the file. Input is the HBase table. It is the HBase table which is the input. Okay. So every record is a row of the table here. All right. So we don't have to define a row. We don't have to define a row. Therefore, we only define what is the output, what is the data type of our output key value. Okay. So you remember in our HDFS MapReduce, there were 4 data types here. Here there are only 2 data types because input data type is fixed. Input data type is the table or the row. Okay. So So we can say that my mapper extends table mapper here, and we are also saying that our output key value pairs are these, and afterwards we are saying that this is the column family name. We are also converting it into bytes. If you remember, everything row key, column name, and the cell value, everything is a binary data. So we have to convert every string into bytes and then use that. Okay. So here if you see our map function, as an input key, input record, it gets the full row. This is a full row it's getting, and then in the context we are going to put our result. Similar is the case with reducer. Reducer extends a class called table reducer, and reduce here in reducer we define what is the input data types and what is the output data type. Okay. So once that is done, we will get the key and the list of values like this, and then we can save it to the disk. All right, we can save it to the sorry. So we'll get the list of iterables. So whatever our mapper has produced as values, they all be grouped together for a particular key in iterable, and then it is up to reduce what to do with these values. Should it pick up the maximum? Should it be concatenate or do some other magic, compute the average or compute standard deviation? Whatever it wants to do, it can do. And once it has done the required operations, then it can save the key and the value into the context. In context, we always do put because it's going to go into HBase. All right. Once you've created mapper and reducer both, all right. So once you have created mapper and reducer both, then you can create a configuration object. Okay, you can create a configuration object, and that configuration object is basically hbase.create, and afterwards you create the job just like we did earlier, and then this basically the driver code. Okay, also here again you will notice this scan object. So instead of running mapper reducer on the whole table, we can also limit ourselves to run it over part of the table. All right, and then we say that we initialize our mapper, we initialize our reducer, and afterwards we say that job dot wait for completion. So we are creating job from here onwards till this point, and then we run it here, and then if it's not successful, we throw an error. All right, so that was our mapper. All right. So there's a question from Pankaj. Question is, we can use Java code to access HBase in any Java project or only in Hadoop based project. So do we need to, let me answer. Let me answer one part of it. Very good question. So any project, okay. So it's basically HBase is a service, and you can always connect to HBase from the remote. Okay, as we talked about the architecture earlier. Okay, so just that the HBase client is only available on the nodes on which we install HBase, but you can install HBase client on any machine which is allowed to connect to HBase cluster. Okay, so you can install HBase client anywhere, and then you can talk to this server. Similarly, you could install HBase, you could put HBase client jar. There is a HBase client jar. You can find it in your lib. If you go into the installation, then you can put that into, you will have to put that into your dependencies in Eclipse. Only then you will be able to make this code run. Okay, do we need a jar for this? Yes, as I just explained. All right, great. All right, so I don't have a running example of this right now, but it can be executed in the same manner the way we executed our MapReduce. All right, there's a question from Rohit. Question is, how is the Java code for creating HBase? Is it executed uh, by directly executing Java code in HBase client? So it is an independent program. Okay, so if you look at this, okay, it has to be in the public static void main of your program, and then you can simply run it. Here it will make a connection to your HBase and then try to get it done. All right. Makes sense to you? Question, very good question from Srinivas. Question is, where is the output of the reducer job in HBase? It is in the database table. Sorry, this is going to be an HBase table, and that we have defined here. While stitching the job, this is where we define. You can see that the target table here, it's a name of the table which we are providing. Okay, this is the source table and this is the target table. Is that what you're looking for, Srinivas? Great. All right. So was he able to answer your question, Pankaj and Rohit? All right. I think there's a continuation to okay to Rohit's question. So his further question is the font clear? Let me increase the font a little bit. So question is, so we need to directly use Hadoop jar file to execute? Not really. For for if you are trying to just read the data from the H base, then you don't need Hadoop jar. Just like the way you execute your normal program, you will be executing this piece of code. Okay, so this piece of code, this is the one which you're talking about, right? Yes, this piece of code you will be executing directly as if you're connecting to any other database. Just that the HBase library, HBase jar file, the client library has to be in your class path. Okay, so you'll be connecting to HBase at a particular port, talking to it in terms of get input, and then um, get your work done. All right, good, very good set of questions. All right. So now there is a very interesting concept called Bloom filter. In Bloom filter, so in Bloom filter, we try to optimize upon the total number of requests a server is getting. Although the Bloom filter is enabled by HBase default, you don't have to do much, but still, it's important idea to know and learn because it's not only HBase which depends upon Bloom filter, but there are many components, tools which use Bloom filter. In the similar fashion, there are independent uh, components that you can import in your project which will act like a Bloom filter. So you can use Bloom filter in your project as well. There are libraries, there are components. So a Bloom filter is an interesting database construct, data structure construct. It's a kind of statistical way of getting things done. All right. Now, let's imagine that there was this reception at your office. There was this reception at your office, and there are lots and lots of requests coming in continuously. And are the most of these requests have are to be rejected. Only there are these few requests which are genuine, uh, okay, which go through. So this is your, let's say, office reception. Okay. And there lots of people come in and ask, am I in the list? Am I allowed to go in? Or can you just find my name in the list? And reception person searches their name in the list and let the person go if his name in the list. Now this reception person says that, hey, I'm heavily overloaded, can you help me out? Can you help me out? So first thing you do is that to the reception person, we give him a list of sorted names of all the people who are allowed to go in. Okay. So we give a big list of, we order the list. Now the reception person's life is little, I mean, fairly easy. But again, since the data keeps on growing, this list in which reception person has to look up quickly, even if the data is well indexed, still it will take a fair amount of time. All right. Now, after a point of time, reception person says that I'm still overloaded, and there are these people who don't exist in the list. They keep coming all the time. Can you help me a bit? Okay. Can you help me a bit? So what you do is you create two level of reception scanning, two level of reception. One who does the rudimentary check, and if there is a red flag, it quickly uh, denies. But if there is a true flag saying yes, you are allowed, the second check happens. Okay, the second check happens. So your actual reception shifts a little bit inside. Your reception shifts a little bit inside, and there you put another reception and you give it a name as Bloom filter. Okay, now the question is, what is it that Bloom filter does so that it can do things quickly? Instead of searching on the full name, it just searches on the hash code. Or for simplicity, let's say it only has the list of people with their first three characters. Okay. So instead of the full names, it only has say first two characters. So instead of Sandeep, it has Sa. Instead of Rohit, it has Ro. Instead of Pankaj, it has Pa. Just for the simplicity's sake, I'm saying that we trim down the name of the people so that the life of Bloom filter becomes very easy. Now, if you look at this, if it's given this kind of list. Okay, so in case Bloom filter says no, that means it's definitely no. But if Bloom filter says yes, it's not necessarily yes. The actual check has to happen. Because imagine that a person comes that, hey, I am Sanjeev, am I allowed? So Bloom filter will say yes, while there is no Sanjeev. Sa has come only from Sandeep. Okay, so in our actual list, you can see, let's say Sandeep, Rohit, and Pankaj. These people are allowed. Okay, so when Bloom filter says no, it's definitely no. Because let's say a person called Ryan comes in, because Ryan starts with RY, which is not there in this list. So it can quickly say, hey, you are definitely not in our list. Okay. While if a person like, say, Sandeep comes in, so it can definitely say yes. But in case a person named Sanjeev comes in, okay, a person named Sanjeev comes in, Bloomfilter says yes, while the actual lookup results in no. Okay, the actual lookup results in no. All right. Is it clear to everyone? All right. Great, great. So in the same way, here also I have tried to depict the same situation. Okay. All right. Now going ahead with the Bloom filter. So okay. So again, when the user comes and ask, say, do you have a key one? So Blink filter checks in the hash code. The example which I gave is not correct, not really. We don't pick up the first two characters. Instead, we pick up the hash code. What is hash code? Converting a big string into a number, into a small number, so that we can quickly use arithmetic and other operations to look up for the hash code. Okay, so a user comes in for key one. Bloom filter says, hey, I don't have the hash code in my list. Therefore, it's definitely no. But if it says that yes, I have, there are two cases. One, the person may exist in the actual storage, or person may not exist in the actual storage. Okay, that's how filter stops a lot of unnecessary spam to our servers. Okay, filter stops a lot of unnecessary requests to our servers. This is a very important aspect of Bloom filter, and therefore it is used at a lot of places. Okay, therefore it is used as a lot of places, because when Bloom filter says yes, no is definitely no. But if Bloom filter says yes, it may be there in our actual records. So how is it used in case of HBase? So Bloom filter on HBase can be enabled per column family. By default, they're enabled. And each Bloom filter, when we say on what level, on what basis is going to look up, what is the unique identity, or what is the hash code of what values hash code is being computed, that can be is configurable. So you can configure that your Bloom filter type is row or column. Okay. If you say Bloom filter type is none, there will be no Bloom filter anymore on your table. If you say row, that means the row key will be considered for computing the hash code. But if you say row call, it means row combined with column values is used for hash code. Okay. So that way you can compute the hash code of a particular row. Okay, either by row key or by row column combination. All right, sometimes you want to put triggers on the database side. Why would you like to put triggers? Let's say you don't want certain users to be accessing data, or you want to take certain action before some change happens. In those cases, you could create coprocessors. Coprocessors are exactly like database triggers, or you can say the backend event handling. Here in the coprocessor, we are saying that please execute my code before or after. We specifically say whether we want to run it before or whether we want to run it after. If you want to run it before, we say pre. If we want to run it after an operation, then we say post. Let's say we want to run our code before a user gets the data. Let's say whenever user tries to access the data, we want our code to validate whether to allow the user to access this data or not. To do that to do that we say get pre-get. And so here you can see here, so we first create a Java class like this. Okay, which extends base region observer coprocessor, and under this we override the pre-get method. Okay, and then we'll put our logic here. We are saying if access not equals to allow, then throw an exception, access denied exception. Okay, so every time a user accesses a value, your pre-get is going to be called. All right. Similarly, you can have pre-delete. If you want, let's say you want to put the value in trash. You want to create a table called trash, and before data get actually deleted, you want to put the data into trash. In those cases, you can simply implement pre-get, and that will do the job. All right. So there's a question from Rohit. Question is when Bloom filter is used. Okay, so one is when there is a mammoth task of searching. Okay, so mammoth task of searching slash lookups. So let's say there is a service, it's getting lot of requests from the user. Okay, mammoth task of searching and mammoth task of looking up the records which do not exist. Okay, so when in your server, if you notice that there is a huge request for searching the key and values where key does not exist. Okay, meaning if your server is being spammed heavily or there are other ways, in those cases you could use Bloom filter to minimize number of requests coming in for you. Similarly, so basically when you want immediate no, but uh, but for yes, you are okay to tolerate a little bit delay. Okay, in those cases you use Bloom filter. Make sense, Rohit? All right. So this is how you define a coprocessor. Now going ahead with coprocessor, what do you do once you have written this class? You create a jar, you put it in hbase lib folder, and also mention in hbase-site.xml. Now when you mention in hbase-site.xml, you will have to put your name of the class here. Now inside this particular key. So please note that you will have to put this jar file which you have to compile this code, put a jar file and put it on all the region servers. And also this change in HBase site you have to make in all HBase region server. Therefore, HBase comes up with this nice idea about uh, setting an attribute on the table. You can set an attribute on a table whose name could be coprocessor $1, $2, $3, or whatever. And then you could specify the name, the path of your jar file. This path is in HDFS. Okay, you can specify this path in your jar file in this following manner, and this will basically pick up the coprocessor from HDFS and run it on every region. So the important bit here is on a column, on a table descriptor, on each table you can add attribute with this name, okay, containing, and the value would be the path. All right, so that is a coprocessor. Okay, so all right, sometimes you want to access HBase from the HBase client, okay, or from and sometimes you want to access HBase from the REST API. Let's say you want to access HBase from the browser or from your JavaScript. Then you can simply start your REST server on the server side and then use the REST API. And what is a REST API? REST API is a way of calling the server from the URL and without having to write any specialized client. Okay, so the URL or the scheme is standard for all kinds of scenarios. It starts with scheme colon slash slash, then login colon password at domain, and then the port number and the path to the file, and then the arguments, followed by a fragment which stays on the client side. Now you can make a call to HBase from the browser or from the any of the REST clients. Okay, now let's have a look at it whether it's working or not. So we'll have to first start our HBase client. I'm using this port so that even if you are an end user, because end user cannot on Unix, end user cannot create a port less than 1024. Therefore, only root can create the port, create a listen to a port less than 1024. Okay, now we have started our REST interface. Now we can go to H2 because I was on H2 server and say H2 colon, what was the port? 111111. Correct? We are connected to H2. Yes. You can see that it gave us the list of table. And then you can say web table, and then you can say hortonworks.com slash, what was the row key? I think this was the row key. Let me have a look at the data. So if we go back to our file, not file browser, we will say data browser at space. Okay, so you can see that the row key is hortonworks.com. Row key is hortonworks.com. So you can see here what we are saying. We are saying table name, then row key, then the column family, column name. Okay. Now let's say contents anchors. Okay. Here contents. So when we say contents, all the columns for contents for this particular value has been written. For this, what was that? Yeah. For if you say contents, there's going to be returns. Or if you want to say anchor, okay, you get this data. So anchor is VM in this case, while this content is in HTML. Therefore, it has opened that way. You can see that the content is HTML, where it is saying a href equals to this, while anchors is just VM. All right. So this way you can call HBase from REST interface. All right. So yeah, that was our REST interface. If you want to connect to HBase using SQL, you can use Phoenix. Phoenix is, I think, installed in our Phoenix is also installed in our server. Here in case of HBase, where is HBase? Yeah. All right. So inside the config, you will notice that the what was the config? Yeah, here. So Phoenix is already installed, but it is just disabled. You can enable the Phoenix and start using. Okay. So that was about HBase. All right. Any other questions at this point? Good question. Good question. So from Rohit, can we use Hive or BigQuery to query HBase? So the way you can use is, if you remember our pig loader, when we were saying A equals to load X using pig loader, it was loader or catalog, right? In the similar manner, instead of using pig loader, we can use HBase loader. Okay. So the data will be in HBase. HBase doesn't provide its own query. In the similar manner, while loading from we can use Hive to load data from HBase. But again, neither Pig nor Hive provides you to insert update the data. Therefore, you will have to go with some other technique. Make sense to you, Rohit? All right. So that was pretty much about HBase. All right. That's pretty much about HBase. Now let's move on to something called a zookeeper. All right. Should we start the zookeeper now? Yes. Great. All right. So All right, so when we talk about distributed computing, it's not only about HDFS. There are many more things to big data or distributed computing than the HDFS. Probably almost every computing paradigm has been impacted the day you try to move a logic to multiple computers. The way every aspect of computing happens has been impacted because of distributed computing. And threads are not an exception. So threads were great. If you remember threads, if you guys are from the Java, C++ background, so threads were a way was a way to utilize to get multiple things done parallelly on the single machine. Now, to to acquire concurrency, to achieve concurrency, threads were great. Threads provided constructs. But what if we are trying to achieve concurrency on multiple processes? If our program is running on multiple machines, we cannot really block each other. We cannot have synchronized. And that's where the problem starts. Okay, so all right, that's where the problem starts. So before we starting the discussion, let me ask you a simple question. Let's say you are trying to process emails. You have written this beautiful processor which opens a user's email, read the email from the inbox, and then process it. In processing, it might be maybe creating indexes, it might be scanning the email from viruses. And in my previous company in the T-Bits Global, we did write a brilliant email processor for doing all kinds of magic. Or maybe it's the other use case of such kind of thing is, let's say you're building a kind of a support, kind of a help desk support in your organization, and what you want to do is you want to provide the two-way email integration. There is an email ID for your support, and that email ID receives the email from people, and your system reads the data from this email ID and email inbox using POP, and then creates a database entry and sends updates to everybody that your request has been logged. Okay, so imagine this. So you have this inbox which has POP3 enabled, and you have these email processors which do a very heavyweight lifting. So you realize that you cannot run email processors on the same machine. All the you start multiple instances of email processors over the network, and that's where the problem begins. So you have these email processors which are reading the same emails. How would you avoid a situation like two email processors are trying to read the same email? How would you ensure that two email processors are trying to read the same email? Anyone? Peter says that put a log semaphore on email to indicate. Interesting, interesting. Or let's say here I'll just try to put one more clause that you are not allowed to modify the inbox. You have only the read only permission. Yes? So, how would you construct such kind of a locking mechanism? Also, please note that these email processors are running on multiple machines. So, creating a synchronized construct is different because they are not part of the same virtual machine or same machine, same process. They are different processes. Anyone? So do you get the problem? Was I able to explain the problem? So objective is you have this code which reads email and does some magic. And this code needs to be run parallelly on multiple machines so that emails get processed easily. And this code keeps running forever. Emails keep coming, they keep reading, and they keep processing all the emails. Now, what we want to avoid is that two email processors competing for the same email. You want to avoid that kind of scenario where two email processors are trying to process or are processing the same email. Good. Xiao's point is that add email processor controller such as a central point and assign job to the email processor. Good. Good. Any other? Rohit says that by storing some log in any central configuration per email that it has been processed or is being processed so that it is not taken by any other processes. Brilliant. All right. Great set of answers. All right. So first, these are the few answers. All right. So yeah, and right. So all right. All right. So good. Good. Now here, if you see, Srinivas says build a queue and load all new emails, and email processors can read from the queue and remove from the queue when picked up for reading. Brilliant. This is a very great answer. All right. All right. So yes. So we can also do this kind of thing, and we will discuss this aspect when we discuss Spark streaming, so that we all have a clarity on what does it mean. One way of doing things in parallel is by putting things in queue and let multiple readers read from this queue. Okay, so very good point. All right, so we are going to go with Rohit's answer and Xiao's answer. The technique here is to have a central kind of a database, maybe a MySQL or maybe some other system, where we mention that this is being processed and this is what has already been processed. Or let's say email processor 1 comes in, starts reading email ID 1, but before that it goes to email processor first goes to under process table, and there it tries to check whether email 1 is being processed or not. If it is not, then it starts processing and also mark there in the under process that hey, I'm going to process it. So the email processor second one comes and checks whether email 1 is being under process or not, and then if it is under process, then it picks up email 2. That's how it makes sure that the single email does not get processed by multiple nodes at the same time. Okay, so these are the questions, these are the real questions when I interview, and when we used to interview earlier for people for large kind of backends, and we wanted a distributed computing kind of team, we always had this kind of questions, not like a typical the questions. So the kind of questions we used to ask in interview is first Bloom filter kind of questions, then this kind of conceptual questions, then the we will also discuss something very interesting today called how does the election happen. So these conceptual questions is what um, most of the people do ask in interviews. Therefore I always make sure that we discuss those aspects. Okay, so and it's a very common thing, it's not a difficult thing to think, but if you encounter it for the first time, you will find it strange. All right. So So that's where, to solve such kind of problems where multiple processors, multiple processes running on multiple machines, to help such kind of processes, we need Zookeeper. We have Zookeeper that helps coordination of multiple processes. So this box is Zookeeper. Okay, so Zookeeper is a distributed coordination service for distributed application. Now, what does it mean? These are distributed application, email processor 1, 2, 3, meaning same logic of email processor running on three different nodes and talking to the various services. Now here when I say this is distributed service, meaning inside this box there are many zookeepers running. There are not a single zookeeper. When I say distributed coordination service, it means there are many zookeepers running parallelly. So a zookeeper gives you a set of primitives which are very easy to program to, uses a data model like directory tree. It is used for synchronization. It is used for synchronization and also used for configuration maintenance. Now, coordination service, it is basically a great coordination service which does not suffer from race conditions or deadlocks. Deadlock is a scenario where, so who can tell me the difference between race condition and deadlock? Difference between race condition and deadlock. Anyone? Rohit says deadlock means two resources waiting for each other. Okay, two or more resources having a cyclic dependency. Good, good, Rohit. Pankaj says multiple threads less processes modifying at the same time. And I mean, one is reading and other is updating is a race condition. Or, very good point, Pankaj, thank you. So, when multiple threads or processes try to compete for the same resources, whether for writing or modifying, although at least one of them is trying to modify, okay, both of them can also be modifying. So those are called race condition, and deadlocks are when multiple resources are waiting for each other. So this zookeeper is somebody who doesn't suffer from race conditions or deadlocks. Okay, so the design, when you try to build your own system, when you try to build your own system, for solving these kind of problems, solving these kind of problems, you would realize that it's not so easy, and that's where Zookeeper comes in. Okay, if you want to try Zookeeper, you can download it, or it's already there in our uh, or or simply run Zookeeper client on our CloudX Lab. Okay, so you can simply go to CloudX Lab and start using Zookeeper. Okay, also note that Zookeeper is already in use. So HBase is already using Zookeeper. Name node and backup name node use Zookeeper. So almost everybody is dependent, including HDFS. Almost everybody is dependent on Zookeeper. That's why we are discussing Zookeeper today. Although nobody talks about it, but yes. So that's Zookeeper. Now let's understand the data model. Okay. So we told that in Zookeeper we can temporarily keep data so that we can coordinate between other services. right? That's what we are doing. So it's kind of a database, or is it kind of a file system? Okay, so it's actually kind of midway. It's a big tree. If you are from data structure background, you will be able to understand what is a tree. Tree, or it's not a big deal. So the data in Zookeeper is stored in the form of a tree, and the each node of a tree is called Z node. Okay, it's a top down. It's a inverted tree. So at the top you have the root. This at the top, this is the root, where this is the main top level Z node. All other nodes are the children of this Z node. All other nodes are children of this Z node. So slash Jew is a children of slash Jew slash duck is a children of this. And so basically every node can be represented in the form of a file path. We can say this node is slash Jew slash cow. Okay. So the data model in case of Zookeeper is in the form of this tree structure, or you can think of it like a directory structure. Just that, unlike in directories, that directories can have file, but file do not have any children. Unlike that, here every node contains data and every node has children. Every node contains data and every node has children. So a znode can have children, znode can have data, znode have hierarchical, znodes form hierarchical space. And when you modify the data on, say, this particular node, you either update, delete, or or but you either update or delete, or you read, but you never append or you never alter the data in place. You never edit the data, right? Therefore, there is no append operation. There is no what do you say, alter operation. There is only set, get, or delete. And all of these data access, or read or write, is atomic, either full or nothing. It will not give you partial data and make you wait. No, it will give you full or nothing. So this is the data model which Zookeeper has. All right. Now, so you can see that we will show you ls slash. So ls slash means we are connected to Zookeeper. You can log into Zookeeper by saying Zookeeper desk client by yourself, and it shows that these ls, yeah, that at the top level we have these nodes. Okay, if you want to go into any of these nodes, let's say we want to say ls slash 17 October. So under this 17 October we have these many nodes. If you want to see what is there inside y, we can go further, and under y we can again go further. You can see that under this particular name node, there's a big name, there is nothing inside it. Okay, so that's how the tree structure is formed. All right, all right. Okay, all right. Thank you, Anand. Your answer were there, but somehow I missed it. All right, good point, Anand. All right, sorry for missing your answers. All right, because you're organizer, so you see chat and others see questions, and so I focused myself on the questions only. Okay. Also, please note that we can get the data of any node at any point of time. So we can say get this, and it shows you that this particular node contains this as the data. Okay, and let's see what is there inside y. Okay, inside y also it is the same data. And what is there inside it? Actually, I created it that way. Yeah, inside 7 October contains this data. Okay, so everybody clear about the data model? So what exactly is, so it is not like our name node, data node. No, it just the way when we are defining a file system, we have files and folders. Similarly, Zookeeper provides you a way to store data, and that way is in the form of znode, in the form of this idea called a node. Okay, it's idea called a particular node, a particular um, structure, okay, in which you store data. This data node is not that data node. Okay, all right, is it clear to everyone what is a z node? So everything here, when I'm right now logged in into this is the Zookeeper command prompt. So here if you say ls slash, we are talking to Zookeeper. It is showing all the z nodes below the top level z node called slash. So we have registry, controller, these are all nodes. Okay, and similarly 7 October, you can see that these are all z nodes. If I want to get the data about them, I can say get slash get slash. So it shows there is blank here, and they haven't put any data. Let's say, let's just check what is there in. Okay, in case of registry, it shows then there is an IP address. All right, there is an IP address, and then under the controller, it is somebody's IP address. Under the controller, it's some other data. See that? Version number this, broker ID this, timestamp is this. Interesting. So basically, it's the this data is for its data is for another tool called Kafka, which uses Zookeeper. Peter, did I make sense now? No? All right. So okay. So again, so let me try to explain once more. So when we try to store the data in HBase, we try to store the data in the form of tables, right? Here, we are trying to store the data in the kind of a folder structure. We are instead of so we are basically creating folders and putting data, other folders inside them. That's what is a Z node. Okay, you can think of it as a like folder which also has some data. Each Z node. All right. So So for example, as I showed you that you can say ls slash and it shows you all the nodes which are at the top level directory. If you want to go in, you want to check what is the data of each one, let's say get slash this, it gives you the data about that and also more information about that particular z node. So slash is a z node, these all are z nodes, and 17 October is also one of the z nodes. All right, so that way, so there are multiple kinds of z nodes. The one which we create by default is persistent. And how do you create this? You can simply say create slash my node. Okay, so you can simply create and you can say my data, and these are automatically getting converted, which I don't like. All right, so we can simply say create my node and then my data. So this node has been created under slash under slash. You can see this is my node. and I can say get slash my node. See that? It is the my data. All right. Now, sometimes you want a node to be temporary, as in a node that is representation of our session. As soon as I exit, this node should disappear. Okay. This node should disappear. So the way I create it is create minus e, and let's say let's create it under my node above my EPH. Okay, this will disappear. Sounds good. Now let's try to create such a node. So I created my node, my this EPH node under this node. Okay, under my node. So this node will disappear. Let's just exit and then connect again. So it will be visible to all of you for some time. So right now it's visible. After some time, after around 5-10 seconds, it will disappear. All right. So this is called ephemeral node. Ephemeral nodes are deleted if the zookeeper session ends. Here we have just exited zookeeper and then connected again. Now you can see that previous session has exited. Therefore, ephemeral node has disappeared. Okay, so these ephemeral nodes are deleted by zookeeper as the session ends or session times out. It cannot have a children, not even ephemeral ones, though it's tied to client session, but it is visible to everyone. Now you understand that. Similarly, if you look at here, there is something called HBase in unsecure. Okay, so under HBase unsecure, you have these region servers. Do you see region servers somewhere? These are the region servers. Okay, you see their names. These are the region servers. If these region servers exit at any point of time, they will disappear from zookeeper. Their name will be deleted as soon as after few seconds of their disconnection. This way, this list will always be fresh. This list will be fresh, containing only those region servers which are up right now. And that's a very big use case of zookeeper, and there's a very big use case of ephemeral nodes. Okay, ephemeral nodes help us in discovery of currently running systems. Make sense to you? So you can see that, so it creates a node with a sequence number. So all right, sorry. So we talked about two kinds of nodes: persistent, and second was the ephemeral. Now, third kind of Z nodes are the sequential node. A sequential node is a node which gets automatic sequence number. Every node in Zookeeper has an internal sequence number. Okay, it counts how many children each node has. Okay, and that is basically a sequence number. Okay, that number does not decrease if a node is deleted. It keeps going forward. Okay, this is called sequence number. Sequence numbers are great if you remember in any of the content management system or any of these existing any of the typical IT system. There's always a request ID. There's always an ID, a sequential ID, which helps people say that, hey, the request number 13 is pending on you, request number 1315 is pending on you, and so on. So basically, in those kind of systems where you need an ID generation, sequential node are very helpful. I'll show you in our node. I'm going to create sequential node. So how do I create? I say create minus s. I provide the parent node and the name. This name, you see name, or let's say P. P is the prefix. It will become the prefix for the new node created. And here goes my data. See, it says that slash node does not exist. So I'll have to say my node. Okay. Now you can see that it has got ID as 1. Okay. It has got ID as 1 automatically. If I run it again, it will create one more node with ID called 2. Okay. Now if you see here, there are only it did not start from 0. Ideally it should have started from 0. Why? Because there was already one node created under my node. You remember our my EPH? That was the 0th node. So every node has got this running counter. Every node has got this running counter, and that becomes the suffix for the sequential node. Okay. So in sequential node, the name is automatically generated. You only provide the prefix. If you keep on doing it again, let's say if I put x here, so I'm saying now my prefix is x, but the sequence number will be 3 because 1 2 has already been generated. Okay. If I say blank, then it will only generate like this. You can see that 0005. So a sequential node is the one whose name is generated automatically by suffixing the current running number of that particular node, to the prefix you provided. So here we are saying we are providing zoo as prefix, and it automatically generated 8 xyz and so on. Okay. So if I create a fresh node under, say, one of these, so one of these, okay, this is what you call inner. I'm just putting some random I. Now you see that here the counter has started again from 0. Why? Because it's a fresh node. Okay. So every node has its running number, and based on that running number, this suffix is generated for the sequential node. I missed, yeah, two questions. So let's pick up those questions. Those are very important questions. One is from Srinivas, and that is from uh, Rohit. All right. So I hope this idea about Znode is clear. There are three kinds of Znode: normal, which is persistent; ephemeral; and sequential. Okay. Then after the break, we will jump into the architecture and answer the questions from Srinivas and Rohit. All right. So the question from Srinivas, where is Znode and its data stored in HDFS? No. On all Zookeeper nodes in local file system. Okay. So Zookeeper does not depend on HDFS. HDFS depends on Zookeeper. So the data in region server is also deleted when ephemeral. Okay, so here the question is these. Okay, it's a very genuine doubt. So question from Rohit is that as we saw, as we saw that there were region servers listed here, right? What happens to their data? So idea is that here there won't be much of a data. There won't be too much of data. It will be only it will be only the name, not the data. Okay, it's only the name. It's a very minuscule data. So if I can say, so it says the data node does not exist. Let me try to understand. I think the node is stretching from here to here. What am I trying to show you is that it's not the complete data that's stored here. Okay, so you can see that it's only this small number, maybe a timestamp or something, which is stored in this. It's a very small data. All right, it's a very small data. So that region server's data is in the region server's data is okay. Region server's data is in HDFS. Okay, so every service can store their own data anywhere. It's not storing in Zookeeper. Zookeeper is only for kind of very small data, kind of an attendance system that hey, I'm up, I'm up. So, okay, only for communication purposes. Did I make sense, Rohit and Srinivas? All right, all right. Let's take a break for 10 minutes. Back by 8:47 a.m. IST. Hi. All right. So should we start now? Is Sumati back? Should we start, Sumati? All right. So we were discussing about zookeeper. So Sumati, are you back? Should we? I want to answer your question. All right. I think she's not back. All right. So Anand is saying that these nodes are nothing but the resources located for processing. Anand, are you back? Yeah. All right. All right. Let me explain something till then. Okay. So we were talking about sequential node with so there are different kinds of node in this storage. The way a file system has files and folders, similarly, this Zookeeper provides you a storage in the form of Znode. The way you create Znode is by using create command, and by using ls you can see the list, and by using get you can get the data of a particular data node. These are logical way of presenting data and nothing more than that. All right. Now, going ahead, so with respect to architecture, Zookeeper generally runs in standalone and replicated. Standalone is like where Zookeeper is only one machine and is running. Okay, that's a standalone. It's just for testing. It doesn't have the high availability. So the Zookeeper also runs in replicated mode, meaning it runs on a cluster of machines. It runs on cluster of machines called ensemble, and this ensemble is basically a very so Hadoop. So Zookeeper also runs in a replicated mode. What does it mean by replicated? Means for high availability, we put multiple machines on which Zookeeper runs, and these multiple machines are called ensemble. It tolerates as long as there is majority. So as long as more than 50% or equal to 50% nodes are up, it will tolerate it will tolerate the failovers. But the moment either 50% of the node or more are down, Zookeeper will become read only. All right. So Sumati and Anand, are you back? All right. Okay, good, good. Let me answer your question before I get into the architecture. So Sumati's question is: so does Hadoop use Zookeeper to find out if name nodes are down? Brilliant question. So yes. So Hadoop. So HDFS uses Zookeeper for discovering the backup name node, and name node, primary name node, and backup name node, right? In case of name node, if you want to configure it for high availability, you can use it uses the Zookeeper to discover which is name current name node and which is the alternative backup name node. Okay. Now, so other is that other question from Anand is: these nodes are nothing but resources allocated for processing. I would say these are just storage. These are just storage. No processing. Okay, it's not like name node, data node. No, it just zookeeper is running on these. Zookeeper is running on maybe one node, more nodes, and you're talking to zookeeper, and the way zookeeper understands things is in terms of z nodes. You tell that please create this particular node, and put the data. So z node is more like a folder, okay, in which you could put the data which are children as well. All right. All right, with respect to architecture, this is very important. All right, so let's try to understand the architecture. So, the architecture of a zookeeper service is highly available in the sense that zookeeper doesn't is not just a single node, it's not just a single process, it's a bunch of computers. These bunch of computers are called ensemble. Ensemble is you install Zookeeper on multiple machines and tell each other about others. So they form the ensemble. You give the name to the ensemble and then say start. And when you start this ensemble, something very interesting happens. When you start these bunch of computers, a bunch of processes on your network, something interesting happens. They talk to each other. These zookeeper servers, zookeeper nodes will talk to each other. They will try to figure out which nodes are responding how much. So each node tries to evaluate the other nodes. Okay, this is something very lifelike, like bees, like other creatures. So when the zookeeper nodes come up, when it turns on, they talk to each other and figure out which one is faster, which one is slower, which one is responding in how many milliseconds. Now based on it, each zookeeper forms the opinion of other zookeepers, and this way they select the best one, called leader, the one who is most approachable, the node which is the most responsive, for most the fastest one. They elect that particular node as leader. This leader has got interesting job to do. Every write is only whenever somebody creates a node, update a g node, writes data or updates data or deletes data. Those all kinds of requests, all kinds of write or alteration requests go through the leader, the recently selected leader. In case after a point of time this leader defaults, meaning its disk get corrupted, its memory is low, or it shuts down unnecessarily, then somebody else will be made the leader, and the process will continue till the point you have more than 50% node in the network. Okay, if you have less than 50% node or equal to 50% nodes in the network, there will be no election. Nobody will be the leader, and hence zookeeper will not be able to accept the requests which are asking for data modifications, and hence the cluster will become the read only. Sounds good to you? So machines elect a distinguished member called leader based on the responses of the ping. The others are termed as followers. Except for the leader, everybody is called follower. This phase is finished when majority sync their data with leader. So the whosoever is the leader, his data will be synchronized. And also, while choosing a leader, data timestamp is also very important. Okay, the version id if somebody is the one which has the highest version id and also is very responsive, in those cases that node will get the better votes and hence will become the leader. Okay, And as soon as this election happens, then the followers synchronize their state, and in case leader fails, the remaining machines hold election, and it takes around 200 milliseconds. All right, sounds good to you? Great, great. Everyone, the second phase is, all right. So Anand's question is, can you explain the difference between zookeeper nodes and name node? There's no relation between the two. There's no relation between the two. Okay. Also, in case of name node, we elect a name node. We tell that this guy is the name node, this guy is the master, rest are slave. We tell in case of name node, data node. In case of zookeeper, in case of zookeeper, they select each other. And also, there is if you are confusing z nodes, and name node or data node, there is no relation. Okay, Gnode is just Gnode is more like a folder, okay, of files, while name node is a physical machine or a processing engine. Okay, name node is like a process, while this is just data. Okay, the only thing that is common is node, nothing else. Okay, so zookeeper node has no relation with name node or data node, while name node is somebody who who keeps the metadata of HDFS, and data node is somebody who keeps the actual blocks of the data. So name node and data nodes are processes running, while zookeeper is the process who is running and is accepting, is talking to you in terms of z nodes. Okay, you are saying that here is my z node, keep it. I mean, z node is just a folder, or we could have better said it like something called um, the folder, something called file, or something like that. It is not a process, it's just a data structure. All right. Did I make sense, Anand? Great. All right. Rohit's question is this. I'll come back to this again. Okay. I'll come back to this again. Remind me, I have a good example, then you know. All right. So in this diagram, the one which is here, you see, the election is happening here. These are the users of the Zookeeper service. They connect to the Zookeeper, create Z nodes. They put their data inside the Z node. They retrieve the data from the Z node and so on. So basically, they keep on creating sequential or maybe ephemeral or maybe normal Z nodes or directory inside servers. So instead of these being the file servers, they are Z nodes. Okay, so that's what is happening. So all the write requests are forwarded to the leader. Okay, and leader broadcasts the updates to all the followers. When a majority has saved, when majority says, majority means more than 50% of the nodes in the network, when majority say that, hey, I have saved the changes, leader saves the leader commits it, and also client gets the confirmation that, hey, your data has been saved. Okay, only after 50% of the machines have saved the data. Now you can think of it, how how strongly how strong backup it is. So only after 50% of the machine have confirmed that, hey, we have saved the data, only then a confirmation comes to the client. Okay, but important part to understand is that it is not that big a hassle to save it in 50% of the nodes, because that happens parallelly. All 50% of the node, if you have 20 nodes in the network, if 10 nodes say that, hey, I have saved my data, because leader will be leader will be publishing the newer changes to all the followers, and the followers confirm that, hey, I've saved the data. Now you can go back and tell the client. So unless more than 50% confirm, leader will not confirm to the end user who is trying to write the data. Now, Peter's question is, why is it majority instead of all to have saved the changes? Okay, again, the logic lies in the election. The leader will get selected if there is a majority. Now, if I mean, if all will take forever and all will never be successful. If you say all, then it also means that it will not tolerate any kind of failure. Correct? To make the system highly available and also partition tolerant. You remember our CAP? P for partition tolerant. To make the system partition tolerant, it says that we just need majority. And your next question would be, why not three? Why not two? Why majority? Right? So we are clear that why not all? Why not all? Because if we enforce that, hey, we need confirmation from all, then we are saying that we will not tolerate any partition of the network, and we will not tolerate any shutdown or failure of any machine, which is bad. Now, why not one or why not two? Why majority? Majority makes sure if majority has confirmed, then that that means we will always have the source of truth. Okay, we'll always have source of truth, because majority always speaks truth. If there is one person who knows the truth and rest know the false, I mean the rest know something else, then that one person will be considered as liar. Okay, because the whenever the election happens, whenever the what do you call uh, what do we call the when the consensus happens between multiple nodes in order to reach to that this is the latest data, this is the oldest data, in those cases it's the majority which matters. Okay, did I make sense, Peter? No? All right, so these are all part of very important theorem. I'll not put that name right now because I've forgotten the name. So there is a big theory around the distributed computing. We will not get into the technicalities, but we will explain the main aspect of it in very simple words. Otherwise, it become too academic, and it won't be making any sense to all of you. All right. So again, so leader broadcasts the update to all the followers. When majority says that I have persisted the change, the leader commits the update. The clients get the success response. The protocol for achieving consensus is atomic, like two-phase commit. Okay. So this protocol for achieving consensus is what will be benefited if we have more than 50% nodes having the latest data. Machines write to the disk before in memory. So few things you should all note here. First, all of the data on each zookeeper is loaded into memory. Also, all of the data that you write to zookeeper is copied to all the zookeepers. Okay, now you understand that why Zookeeper is not great for big data. Zookeeper is only good for small data. Why? First, the data is being copied to all the nodes. If you have 100 Zookeeper node, the data will be in 100 different places. 100 data will be having 100 copies. Okay. Second is all of the data which is there in the Zookeeper on each node is also kept in memory. Therefore, data has got data consumes a lot of resources in case of Zookeeper. Okay, so it's a trade-off between memory, disk, and and the highly available and consistency. Okay. Also, please note that let's say there is a change that has come into the leader. Okay, and that change will get copied to the followers and will take some time to reach to the follower. So the followers, whatever clients are reading from followers, they will always be reading a little bit older data, but the data is eventually consistent because data is going to flow from leader to all the followers. There is not going to be any inconsistencies in those terms. Make sense to you? All right. Now, there is one more aspect we talked about. Leader should have at least 50% of votes. 50% of the people, 50% of the machines should be up. More than 50% should be up. Out of three, at least two needs to be up. Otherwise, there will be no election. In case there is already some leader, they will step down. In case less than 50% nodes are down. Okay, less than or equal to 50% of the node. If five, the moment out of five, three nodes shut down. Okay, the leader will step down. Okay, leader will step down. That's something very awkward which we find. Okay, so if you have three nodes A, B, and C, and A is the leader, if A node dies, will someone become the leader? Anybody? Let's say we have three nodes in this ensemble A, B, and C. A is the leader right now, and A has been shut down. So, will somebody become the leader? So, for becoming the leader, leader needs to ensure that there has to be election will only happen if there are 50%, more than 50% nodes alive. And what is more than 50% in case of three? Two, right? If two nodes are alive, then there will be election, there will be a leader. So out of three, since two are alive, see that B and C, the two are alive. Okay, so A has been shut down, so we are left with B and C, and then the election is happening. So either B or C will become the leader. Rohit, is that clear? No? Because unlike name node data nodes, in case of Zookeeper, the leader will be elected by themselves. We would not know which machine is running as a leader. All right. All right. Now, what happens? Something very unfortunate happens that we had elected after A got shut down, we made C as the leader, but now B has also shut down. What will happen? Will C remain the leader or will C step down? Anyone? Will C remain the leader? Anand says C will step down. Good. Yes. C will step down. Okay. Now, C will step down and no one will be the leader. And when there is no leader, the zookeeper cannot accept the write request. It cannot accept the request for modification of data. All right. Now, Very important aspect. So you might wonder that had if we had, say, if we had 1,000 nodes and 500 are alive, rest 500 are dead. Okay, will there be election, and will there be leader? Right, right. So the answer is no. The answer is no. There will be no election, there will be no leader. And why is that? Can anybody can anybody tell me why is this? Out of the six node A, B, and C, in case any three shuts down, there will be no leader, and rest of the three which are alive is are of no use, are of only use to give the data to the user. No write requests are given to the ensemble. Okay. So can anybody give the reasoning? Yes, correct, correct. Since there is no majority and we need more than 50%, therefore there will be no leader. But why is this? Why is why is this 50% rule? Can you guess? Can you think about the reasoning why this kind of rule has been imposed? Okay, what does it mean? Why should we have such kind of weird rule? Okay, shouldn't it be whatever machines are running, let they elect their leader and let they be happy? Even though we are left with 500 machines, still we don't have a leader. Shouldn't the logic be whatever is the machine, let it run? Okay, can anybody take a guess why is this kind of weird rule? It took me some time to figure this out. Yes, you're right. Uh, can anybody guess? Yes, anyone? No? All right. So do you know what is the question, by the way? So given in this ensemble, why is this 50% rule? Why do we need to have more than 50%? All right. So the reason the rule of 50% is because of the fear of multiple governments. Fear of multiple governments. Uh, what if people start forming their own separate governments? Okay, in the same way, in this, imagine this, we have these two data centers, data center 1 and data center 2. And also please note that it's not it's not only in case of zookeeper this kind of rule. All the systems which have the same election mechanism, all of them have the same rule for election. All of them, be it MongoDB, be it CouchDB, be it uh, the other systems where election automatically happens, everywhere the same rule applies, that more than 50% should be present for voting. Only then the leader is elected, otherwise the election is invalid. There is no election. Okay, so now let's try to understand why is
this strange rule of more than 50%. And I gave a hint about multiple governments. Now, let's imagine that we had these 6 servers in Ensemble. We were pretty happy that we have 6 machines, 3 in one data center, 3 in another. Good. And now something, and they have elected a leader called A. They've elected a leader called A. We were so the things were going great till the point the connection between the two data center got cut. There was some disconnection that happened between the two data centers. Now imagine if we did not have 50% rule, what would have happened? Imagine what would have happened if there was you could elect a leader with whatever nodes are available in the network. You discover whatever the nodes are in the network, whosoever is available, and they vote, and then we make a leader. Then the chaos will happen. The chaos in the sense that there will be two leaders, one in data center one and other in data center two, and both of them will start operating in their own fashion. And when they start operating, meaning both of them, data center 1 and data center 2, having both separate leaders, accepting the right request from different set of clients. One client once goes to data center 1, other client, then same client goes to the data center 2, and he finds the whatever data he has written in data center 1 is no longer in the data center 2, and that's where the chaos happen. And also, since both of the changes have diverged, there is no hope of merging them back. Okay, there's no hope of merging them back. Do I make sense? Now now there has to be some constraint. If whosoever is available, if they start electing, this partitioning of the network will cause the havoc. It will cause the crisis, right? If imagine if we have 5 data center and we are having 5 different leaders, the whole data is corrupted, it's no longer of any use, right? Because the way client talks to zookeeper, they keep a record of all the nodes in the in the in the in these of the ensemble, and they keep on trying in the loop from end to end. Okay, so some of the client will talk to leader A, some of the client will talk to leader B. Make sense? Are you with me? Did I make sense here? Veena, Rohit, Sumati, Srinivasan. All right. So this is what happens. This is what happens in case there is no. Uh, all right. Now, why this 50% again? Let me try to reason a bit more. So, can there be bigger cake than 51% size? If I'm a finicky kid and I say that it's my birthday, I should get the biggest piece of cake. Okay. So how can I be you know make how can I make sure that I get the biggest piece of cake? The biggest piece of cake is little more than 50%. Little more than 50%. Now once I cut the cake such that I get bigger than the 50%, then I'll be at the piece that there'll be no other person getting the bigger cake than me. I'll have the biggest cake. If I want the biggest piece, I will take little bigger than the 50%. So I will always have the biggest piece of cake. In the same manner, there cannot be any other more than 50% in the network. Therefore, there'll be only one election that would happen. Correct? So that's why the 50% rule. Now, an ensemble of 10 nodes can tolerate a shutdown of how many nodes quickly? Yes? Good, good. Everybody is correct. It is 4 billion. Now, that was about ensemble, the way ensemble election works, who becomes the leader, how does the synchronization happen. Now, with respect to the client, how what happens? There is some idea called sessions. A client as in the client of Zookeeper is everybody. Client of Zookeeper is also region servers. Client of Zookeeper is name node. Client of Zookeeper is Kafka. Client of Zookeeper is what do you call? Even the sometimes there are at least almost everybody is the client of Zookeeper. So the client has the list. This client is also the client library provided by Zookeeper, which other programs can use to to talk to Zookeeper. Okay, so you don't have to do a lot of mechanics. Most of the mechanics is either taken care by Zookeeper or by the client library. Just like most of the mechanics about slicing the file into blocks and talking to the name node and data node is done by HDFS client library. In the same manner, most of this magic is done by the client library. So a client library has the list of servers in Ensemble. If it doesn't, it will gather those details by asking all the nodes that do you know any more servers? Do you know any more servers? And it will prepare. The client library will prepare the list of all the servers. Now the client will start trying each one from end to end until it's successful. Once the connection to Zookeeper from a client is successful, then server creates a session for the client. Server keeps a session for the client on the server side as well. Okay, server here is Zookeeper server. Okay, so server creates a new session for the client. A session has a timeout period decided by the caller. So every client can tell that, hey, I cannot respond to you in less than 1 minute. Okay, so my session timeout should be 1 minute. So don't expire my session if I talk after 1 minute. Okay, so if the server hasn't received a request within the timeout period, it may delete the session. It may expire the session. And once the session has been expired, all the nodes which are part of that session, all the ephemeral nodes which are part of that session will get deleted. Okay. To keep the sessions alive, the client library has to send the pings before the timeout. Okay, before timeout. And these are called heartbeats. Okay, the client library takes care of the heartbeat. You, as a developer, just have to use this client library. It will internally talk to the server, keeps on sending heartbeats. Failover is handled automatically by the client, meaning so failover is handled automatically by the client library. The library your program will be using, it will automatically take care of the failover. In case, let's say you are connected to A, suddenly A got shut down, it will switch quickly to B, maintaining the same session. Okay? Sessions are still valid while switching to another server. Application cannot remain agnostic for server reconnections or disconnections. So although most of the magic is being taken care by Zookeeper and the client library, still you cannot stay agnostic, because if client got disconnected, client might be reconnecting to other nodes, and at this point of time when the client is reconnecting, client library is reconnecting, and your program asks the client to read the data, it will fail. Okay, so your program cannot stay agnostic. Your program cannot say that, hey, I don't care whether you are connected or not, give me the data. In those cases, your program will get the error. All right. So yeah, this is a diagram which shows that the magic starts with the client asking for new, so program asking for new zookeeper, and new zookeeper is now connecting to the zookeeper server, the client library, and once it gets connected, it receives an event saying, hey, you are now connected, now you can start the work, and then it can talk to, keep on giving pings and can start talking. All right. Now, this is probably a better example of how does Zookeeper help. So somebody was asking me, I think Rohit's question was, then how does this region server and HBase is benefited by Zookeeper? Imagine this. On the right hand side, there are programs which want to talk to HBase. Okay. On the left hand side, there are these region servers. Okay, on the left hand side you have lots of region servers, and on the right hand side there are these clients. I'm sorry, so I would say, okay, let me take a step back. I think I'll give you a better example. Imagine that you are running an API server on your organization. This API server is parallelly running on hundreds of machines, and people in your organization are talking to this API server. There could be many clients or many programs which will talk to these servers. Now, from time to time, many of these servers will keep on going down and coming up. From time to time, the clients will come up and ask for a server, right? So either all of these clients keep a track of all of these servers, either that happens, meaning all the clients, all the users of these servers keep a track of which one is up, which one is down. Like we have h1, h2, h3, and I have told you keep trying from h1, h2, h3. It is fine until it's just three machines. If we have 500 machines, it will be unfair to you that I say that, out of 500, keep trying, whichever you get, be happy, start working. That will be unfair, right? Instead, there should be an automatic mechanism of keeping the list updated. And that's what Zookeeper's ephemeral node are about. When That's what the Zookeeper's node are about. Let's look at this diagram. The diagram says that, so that's where the Zookeeper comes into. Zookeeper is some kind of an intermediary between the various clients of various servers. Okay. Now let's imagine that the Zookeeper is up and running, and there is one server as in the service provider. Say, imagine the region server is here. So so these, it says the connect request, and Zookeeper says, hey, I'll let you know once you get connected. And then once it gets connected, it sends the event saying, hey, now you are connected, now you can start working. Then this server says, create one ephemeral node called server slash duck. Now another server comes along and says, that's why I've put a different boundary in the two. And another server comes along and says, create a ephemeral node for cow. Now at this point, when the user comes along and says, give me the list of servers, give me the list of ephemeral nodes, give me the list of nodes under slash servers, it gives duck and cow. Okay. Now after some time, the duck server got killed, which means after 5 seconds, if the client again comes and asks the same question, ls less servers, it will be only the cow, no duck. Okay, that's why the client always get the most updated list of the servers available. All right. So There was a question. Yes, this one. So, Rohit, did you get the answer to this question? No? Could you explain Zookeeper's role in edge-based architecture? Okay. So, basically, region server 1, okay, create some ephemeral node, let's say slash r slash uh, rs1. This is the IP address. Okay. So these are the three region servers which have created their ephemeral node rs1, rs2, rs3. Now HBase master, HBase, HBase master will do the ls on slash rs and will get the latest list of region servers. Okay, now this way HBase master does not have to keep pinging rs1, rs2, rs3 all the time, or does not have to keep tracking that what are the configured region servers are there, right? Because if it maintains the list by itself, then what will happen is it has to also keep on refreshing it, keep on talking to all region servers, and that there will be always a lot of mechanics which can be uh, already taken care of by Zookeeper. Okay, so Rohit, I did not get your question. So in case, so let me show you. If you get here, from time to time, from time to time, HBase will come to Zookeeper and say, "Give me the list of region servers," and it will give the list of region servers. This is the name of region server. It shows the this is the IP address, this private IP address of that particular region server. This is the port, and this is the time since it was up. Okay, so this is the list of region servers. Do you see that? Now, in any case, if one of the region server goes down, okay, then this list will shorten and HBase master will realize that one of the region server is down just by looking at this folder. All HBase master has to do is keep an eye on this. That's all. Is this make sense to you, Rohit? No? So Zookeeper is not replacing region server. Okay, Zookeeper is only facilitating HBase master to discover available live list of region servers. Okay, Zookeeper is just for very small data. Yeah. So question from Rohit is, so okay, so region server will be down and will not send heartbeat to Zookeeper. Yes. Yes. And then region server will be removed from the list. And HBase master will come to know that we have one less region server. We don't have one particular region server. So it starts replicating data. It starts doing all kind of magic. Okay. All right. So that's how the mechanics happens. Now there are few more things you need to know. One is guarantees. The Zookeeper provides a sequential guarantees updates from a particular clients are applied in order. Although Zookeeper will not be able to provide an immediate consistency, a strong consistency, but it provides you sequential consistency in the sense that updates will come in the same sequence in which the user has applied them. Okay? If user first made this change, that change did something else, then though in the same sequence the updates will come to this. Second is atomicity. Updates either succeed or fail. Okay, there is no such thing as partial update. Single system image. Client will always see the same view of the system, whether a client is connected to one server or another. Durability. It will only confirm if it has saved to the disk. Therefore, every change is durable. Timeliness. Rather than allow a client to see very stale data, the server will rather shut down. If one of the region server has not received any request, it will assume that it has been disconnected completely from the system. It should better shut down rather than cater the old data to the users. Okay? There are a few more things which a Zookeeper provides. Okay, such as these are the operation which we have already talked about: create, delete, ls. Other than that, you can also see who has the permission on a gnode. You can set the access control list. Okay, so get children, get data, and sync is few things which you can do on Zookeeper. All the changes, whether update, delete, or create, all of the changes can be batched together in a single transaction. And the meaning of transaction is people either see before the transaction has been applied or after the transaction has been applied. The intermediate states are not visible to anyone. That's about multi update system. There's a question from Dilsad. Question is, do we create do we use create operation to create parent node also? Yes, every node has to be created, right? So except for the slash, which is by default created, rest of the nodes are created using create command. The topmost level node is already created. The rest we can create at any point of time. All right. Now the APIs, one I showed you the command line one, that was the most simplistic. There are two kinds of core API developed by Zookeeper guys. One is in Java, another is in Perl, and there are contributed one from in Perl, Python, and REST. So the core ones are in Java and C. Okay. Now, interesting aspect of this API, all of these API is, all right. The interesting aspect of this API is that they all of the functions have two faces to it. They have two faces of each function. One is asynchronous, other is synchronous. Asynchronous means that it will take our request and will tell us that we will let you know once the request is done. Other one is the synchronous, where it says that please hold on, I'm responding, I'm doing your work, please wait. Okay, that is synchronous. Other is don't wait here, I will let you know. In those cases it's called asynchronous, and we give a callback. Callback is a function declaration, as in what needs to be done once this work finishes. that is callback. Now there is one more interesting idea that is useful in a lot of cases. It's called watches. So instead of client keep on polling Zookeeper for checking again and again whether the folder exists, whether the things have been deleted, client tells this Zookeeper to give it the alerts, to give it notification of changes. Okay, so that's where the watches come into play. So client create watches and Zookeeper gives the notification for those watches. Watches are only triggered once. So if you want to trigger repeatedly recurring events, you have to keep on registering again and again. Okay, the read ops exists. So various kinds of read operations such as exist, get children, get data may create watches. They have one function you can pass to these functions, and that will be used as watch. So watches are triggered by write operations such as create, delete, and set. All right. Now the access control operations such as change the permission, give a permission to somebody, remove somebody from the role, those do not result in any kind of all alerts or notifications. Okay, so the watches of exist, the watches that were created with a function called exists. Exist is a function which helps us check whether a node exists or not. So using exist, we can pass in the the alerts. We can say that please notify me when this node changes. So the watches of exist are triggered when znode is created, deleted, or its data gets updated. Watches of get data are again triggered when deleted, when the node gets deleted or its data gets changed. Watches of get children are triggered when node's data is deleted or it's any of the children is created or anything happens to the children. The get children's watch is notified. All right. Now sometimes since Zookeeper is kind of a global service for all the people, Zookeeper is kind of a network service for all the nodes. Now, Zookeeper will be very useful for many different kind of applications. Therefore, therefore, you have to take care of the security at a lot of places. You have to make sure that one particular user can only access its nodes. Its G nodes will be accessible only for few people. So therefore, the permissioning and the role-based access control come into play. So ACL is access control list that is designed for this purpose. It depends on authentication and authorization. Authentication means could be either digest, as in login password, SASL based on Kerberos, or it could be based on the IP address. Okay, ACL is a combination of authentication, identity, and set of permissions. Okay, so that's about ACL. So we have already done the hands-on, whatever was required for this, and okay, so we have talked about many use cases of a Zookeeper. We can build a reliable configuration service using Zookeeper. It is a distributed lock service. Only a single process may hold the lock. Now, when not to use Zookeeper, that's a very important aspect. Do not use Zookeeper if you are trying to store little bigger data. Okay, when the data grows bigger than the certain extent, then you should not be using Zookeeper. Zookeeper is not for big data. It's good for fast. It's good for it's good for used by many other services. Okay. So it gives us good enough consistency but does not give us strong consistency, as we have talked already, because data gets written first to the one node and then it gets replicated to other nodes. Therefore, do not use Zookeeper when you need strong consistency, or do not use Zookeeper if you are trying to store big data. Why? First, data is loaded into the memory. Second, the data is copied to all the nodes, cloned to all the nodes. So that's one aspect. All right. There was one question from Anand. I think I missed. Question is, so if 50% nodes are down, systems will be unusable till the live node become greater than. Systems will become read only. All right. Make sense to you? So that was pretty much about Zookeeper. So Srinivasan's question is, can you tell a real world example of for implementation of Zookeeper? The first problem, if you see, the first problem itself is a recipe for Zookeeper. Similarly, anywhere your program needs to coordinate with other nodes, then you can use Zookeeper. Now, the question from Anand is, then what is the alternative if we have big data? In those cases, you go with NoSQLs. Also note that Zookeeper, system like Zookeeper, there will be always loopholes in it if you are trying to do the big data. All right? Do I make sense to you? Okay. From the architecture and developer's perspective. So whenever you are creating, let's say I'll give you an example of our case. So Amazon runs the website on around, let's say runs on, say, 200 servers. Okay. All right. And there is some data which need to reflect on the website very immediately. Say for example, some of the configurations. So configurations is not too huge data, but after a point of time it becomes like 100 MB data. So this for configuration reflection on all the nodes so that the website can get the latest configuration. For that, we use a similar service like Zookeeper. Okay. So that is a one real world scenario. So if you have a website where you need to coordinate with multiple systems, you could use Zookeeper. Or if you're building a distributed service where you need to keep track of continuously all the users which are connected. Okay. So in those cases, you could go with Zookeeper. All right. I think I hope I have explained. No. So there's a question from Rohit. Apart from having the differences like column family structure, what is the difference with? So Hive is mostly read only. Okay, Hive is mostly read only, while HBase is read write. Okay, and while Hive is basically a basically a gateway. Okay, so Hive is basically, what should I say? So I think this is the biggest reason. So Hive is mostly like an analytical engine where you can send the query and it gets converted into MapReduce. While in case of HBase, HBase is a database, okay, in which you put any millions of records. Hive is not a database. All right. Pankaj's question is, then it means Zookeeper is alternative to NoSQL if data is not big. Kind of, yes. Okay. So Hive doesn't really provide you a way to store data. It's actually the HDFS where the data is stored. Alright, Pankaj's question is HBase can be used to create data in tabular form and can use MapReduce, Pig, Hive, and Hive to do can use MapReduce, Pig, Hive to do the operation. Yes, that's correct. That's the right way to think about it. Thank you, Pankaj. Srinivasan's question is criteria to choose HBase versus HDFS or both. Generally, you go with both. I'll tell you why. So this question is like saying, should I store data in DB or in file? This is a question comparable to this. Answer is, if you need record manipulation, then you go with HBase. If you just need append only system, then you go to HDFS. Question from Rohit is, what will disable my table do in HBase? Disable my table will start cut offing cutting off the connectivity so that users stop writing to this table. Okay, and then you can happily delete. So Pankaj's question is, correct me if I'm wrong, HBase also yes. Just like your Microsoft SQL also store data in file system. Similarly, HDFS file system, specifically name node stores data in So so basically, if okay, so just like your database stores the data in the file system at the end of day, similarly HBase master or HBase stores the data in the file system at the end of day. Correct? So was I able to answer your questions, Rohit, Srinivasan, Pankaj? Great. All right, brilliant. Now there is a question from Anand. Okay, there are two, three questions from Anand. Let me try to just put all of them together here. Okay, so NoSQL will take care of the job that Zookeeper does in big data. Yes. So in NoSQL, the only problem with NoSQL is that consistency and the reliability will not be same as Zookeeper. It will be little less. Okay. Next question is, if so, for small data, we can go ahead with NoSQL. For small data, for big data, you can go with this. For big data, you can go ahead with NoSQL. Okay. Okay. For small data, you use Zookeeper. Okay. Kind of. So for small data, yes, you can use NoSQL for small data, but it will not give you concurrency and the great consistency, sequential consistency. So the kind of use case we talked about, when there are multiple processes trying to read the same data, all those kind of operations are not possible using general NoSQL, because here in case of Zookeeper, it's trying to get best consistency done by wasting a lot of space and by wasting a lot of memory. Okay, and it's able to afford this wastage because the data which Zookeeper keeps is very small. Okay, so Zookeeper has got its use case. Not only I agree that it's the data that gets stored at the end of day, but it provides you these great facilities like provides you the notification and alerts, provides you a way of ephemeral nodes, keep on trying to connect again and again. Those kind of pains are absorbed by Zookeeper. All right. All right, I hope I've answered your questions. All right, we will continue our discussion from here onwards. Also, all of you, please note that there will be no class next weekend, as per the people from other batches also requested me. So let's not keep a class on next weekend. We will have class on next to next weekend. All right. So no class on next weekend. All right. So for those, this is Friday, Saturday. So for them, basically next weekend there will be no class, both the classes. We will push them by 1 week. All right. All right. Thank you, and thank you for great questions. And keep the questions coming. Okay. Keep the questions coming. These are really, really important questions, and they also help everyone else to get their doubts cleared. All right. Thank you very much, and have a great week ahead. Bye bye. All right. So we have finished Zookeeper today till here. All right. Thank you. Have a great day.